Greetings, students. It's Friday, May 8th. It is about 6 o'clock at night and it's snowing. It's almost 2 months since we've been last together at school. So welcome to my wood shop, my wood turning shop. And many of you know that I'm really big into wood turning. It's probably one of the biggest things that consumes my life right now, is besides my family, is wood turning, and obviously besides school. So being a wood turner, which is a subset of woodworking, a lot of times people throw projects my way, and sometimes they're kind of, well, simple. Sometimes they're a little unique. Here's a project that came from a friend of ours. He needed replacement spindles for his stairs in his house. So there's a few matched up. So for a wood turner, that's not that big of a deal. The project that I'm going to share with you today, I was kind of thinking about giving you a video that was kind of more, not really a lesson in it, but it's more like recreational. You can watch it. I hope you pick up a few things. This project that came my way is very, very unique, and it's certainly got me thinking about a lot of things. I had to do some research, and there's science involved, there's history, a little bit of English with some new terms, there's math, and there's definitely some geometry at the end. So first of all, I want to make sure everyone knows I'm not promoting my wood turning business in any way. I'm not. And secondly, we're going to be talking about bourbon barrels, and I'm certainly not promoting the consumption of alcohol in any way. I just want to show you some really cool geometry and math stuff that goes along with what's happening in a bourbon or whiskey barrel or a wine barrel. So the project that I was after, if we kind of proceed over here to the other side of my shop, is a friend of mine gave me these two barrels that were hanging out in his barn, and they were there for probably about 20 years, and he wanted some things made out of the wood, and specifically he wants out of this top. This top is much nicer than the other side. The other side has stamped writing on it from the company that filled it with their bourbon when it was first filled. He wants a couple of clocks made out of it, and that'll be a pretty cool clock for someone's man cave or kitchen maybe, or whatever. So there's a lot that goes into this. I had to research barrels and figure out a process for myself, and a couple problems arose on the way through. So first of all, a couple things about a barrel. They're pretty heavy, as you can see here. This one, if you look down, one of the hoops fell off. These hoops, you know, look at this. I can pull that metal hoop right off. That's not supposed to happen. These barrels date back a little over 2,000 years, when the Roman Empire reached Gaul. Gaul is present-day France, about 100 BC. The Roman soldiers saw the native people there in Gaul transporting their beer, ale, wine, because the French are known for wine. They found them transporting their liquid goods in barrels that were like this. And the technology really hasn't changed. Again, when you hear the word technology, you think of phones, you think of video games. Technology is just, you know, how we do things. And folks, this barrel is a marvel of that technology, and it remains unchanged. And sure, you see blue plastic barrels, you see metal barrels. Maybe some of you have an old burn barrel outside where you burn garbage in your yard. You know, you see beer barrels or stainless steel, but bourbon and wine, wood. And you know, you think back to when you studied like the explorers and Columbus and all that stuff. How did they transport? You know, they're out to sea for months at a time, 6-month trip. They had to take fresh water with them. How did they take fresh water with them? In one of these. They probably had hundreds of these. So why is this hoop coming off? Why are all my hoops loose? My hoops are loose because this is dried out. And when this wood dries out, it's kind of shrinking. So a couple things are happening here. First of all, these wooden pieces are called staves. And there's one stave in particular that is bigger, wider than all the rest, and that's this one right here. And that's the wide one because of this right here. This silicone plastic seal, that's called a bung. And nowadays they're plastic. If you go back a few decades, they were wood. And they would put the wood in there with the grain rotated, and they pound it in with a mallet. The hole there, don't snicker, that hole is called a bung hole. So this plastic bung is fitting in that bung hole. So this stave has to be the widest one. It's the most important one on this whole barrel. Why is the hole there? Well, if you notice the profile of this barrel, it's curved. Folks, when they cut the staves, they don't cut it on a curve. These things are cut straight. Now the edges are cut at a slight angle because all these staves go together, they have to make a circle. So they have to cut that at a precise angle. It's a very small angle. Okay? It's going in from 90, it's acute, but they have to make it so that it makes a circle. Okay? So right there's a little bit of geometry, a little bit of math. When this is laid sideways, that's the highest point because of the curve, so that you can fill it all the way up. Now if you put alcohol in here, the alcohol is going to evaporate. So there's always going to be some gone. Over the years, people figured out, particularly the French, that there was one wood that was extremely important for making these barrels because it imparted good flavor on what was inside. And that wood is oak. And when the colonists settled here in the States, they realized that our white oak gave a superior flavor. So that brings me to some names. Before we go to the board and we talk about why they're using oak, let's talk about, when you think about names, common names, last names. What's the most common name in the United States? I think a lot of you would probably say Smith. Very, very common last name. Another very common last name is Miller. Another common last name is Baker. And if you're thinking, you're probably thinking to yourself, well, those were names of occupations, and that's exactly right. A smith was a person a metalsmith who made objects out of metal in a forge. A miller was someone who milled grain into flour. So every town, Wyalusing had a smith, Wyalusing had a miller, Wyalusing probably had a baker. Okay, another common name, carpenter. Well, you know what they did for a living. Okay, well, almost every town, if it was big enough, had this occupation. A person that makes barrels is called a cooper. And I'm sure that you've heard that last name. Okay? So, in a cooperage, the way they get this curve, they put all the staves in that bottom hoop. And they put a clamp around there. And all those staves are sticking out like a whole bunch of fingers. And they might even put the bottom 3 hoops on, because every barrel has 6 hoops. They put them all in there, and they put it over a fire. And the fire toasts the wood. It doesn't burn it. It toasts the wood. And just by toasting that wood, by heating it up with a fire, the wood becomes flexible. And then after, and it takes a lot of experience, then they start putting on these hoops. They get these hoops over. And then the last thing, if it's for wine, they don't do anything with the inside. Wine barrels are bigger than this. Wine barrels are about 63 gallons. Bourbon barrels are 53 gallons. That has a funny name too. It's a unit of measure. It's not called a barrel. A lot of people do that. It's slang. But technically it's called a hogshead, and it has nothing at all to do with the head of a pig. Hogshead is a French term because that's where this all originated, was in France. So a hogshead of bourbon or whiskey is 53 gallons. So this is 53 gallons. So one thing that they figured out on the inside is that, and if my cameraman would come over here, if you look at the inside, now I already cut the top of this barrel off. If you look at the inside, the first thing you're going to notice, you're going to see daylight through the seams. There's no nails. There's no screws. The inside is charred. So for bourbon and whiskey, they build a fire in here and they char the inside. And there's a reason why they do that. It imparts flavor and it imparts color to the inside here. Now, what holds this together? You look at this. I cut the top off. Look at all these staves. They're ready to come apart because my hoops are so loose. Now, why are they ready to come apart? Well, what holds this thing together is nothing but friction. It's a compression fit. And once these are full, that wood swells. So if I were to take this one, which has been dry for probably 20 years, if I drilled a hole through that bung, filled it with water, water would be pouring out every crack. But if I left it overnight, a few hours, let that wood swell, it'd be tight as a drum. Okay? Now, how did they extract things out of there? Well, here's another turned object. I found this at a yard sale up in the Finger Lakes, or gift shop or something. I found about 5 of them, and I bought them all because I'm a wood turner. This is a turned item. You're probably looking at that. It's 3 pieces, folks. It's 3 pieces. So what they would do in a tavern, or maybe at home, is they would put this on its side, but first they would drill a hole. And they would pound this. This is tapered. It's round and it's tapered. And I don't know if you can see it, but if you get really close, you can see there's a little indentation there because that's where it sat in the barrel. Right up to there. Pound that in. Folks, there's a hole drilled through there. And there's a hole through here. This hole comes out in there. This part also has a hole drilled in the bottom. And if I rotate it, you can see that hole connects there. So this goes through, right through here, out there. This goes in. That would pound in. The liquid would flow through. This is just a handle. And what's the purpose of the handle? So you know whether it's open or closed. So here you go. This would be, if you look at it, if I pull this out, that hole is in line with this long hole so the liquid could travel. And where does the liquid come out? It comes out the hole down here. So this direction here, if the handle is straight out to you, that means the valve is open. And if you turn it either to the right 90 degrees or to the left 90 degrees, you wouldn't be able to turn it all the way back because it would be, well, maybe, but it would be probably close to touching. But you just go 90 degrees and it would shut it off. Now you might be thinking, well, geez, he's just pulling it apart. Look how loose it is. Wouldn't it leak? Yeah, it would leak. But you know what? Before you pound that in there, if you drop this in a bucket of water and then pound it in, this isn't leaking. Because again, once all that wood swells, you're not going to be able to get that out of there. Now that's a pretty tight fit. And this easily, I did some research on these, and just based on the shape and stuff, I know it's over 100 years old. And again, this came up from Cayuga Lake. I have about 5 of them, and one of them, oops, there goes the handle. One of them is significantly older than that. So the one is speculated to be close to colonial times. But this one's probably late 1800s. Okay, so very simple technology and we're using the wood. We're using the wood to make this stuff work. Now, why oak barrels? Well, let's go over to the board real quick. And I want to talk a little bit about the oak. You probably know from science class, if you look at a slice of a log, there's growth rings. And those growth rings, there's one per year. And that ring actually separates the spring growth, which we're having at this time of year in May, from the summer growth. So the spring growth is when the tree is actively sucking water out of the ground through the root system, right up in. The summer growth is when that photosynthesis is taking place. So the growth rings are separating that. Now in oak has these things called medullary rays. And there are these little rays that go out from the center. Okay? I would show you a piece. Actually, I have a piece of oak right here. This is oak I made some shelves out of for our kitchen back before Easter when the quarantine started. The end grain, boom. So the end grain looks like, you can't see it on the camera, but the end grain is looking like this. And if you look at the end grain of a piece of oak, you'll see these rays going through. And those rays are what make, so if there's the board, those rays are what make oak so pretty. Well, those rays also have something to do with ring porosity. Oak is very ring porous, which means water transfers from ring to ring via those rays readily, quite easily. Woods that don't do that are called ring diffuse. The woods that are ring diffuse are tropical woods. Why? Because they're always growing. They never stop growing. But oak, because it has this ring porosity, and oak, more than any other wood, has tannins in it. And the tannins in the wood impart a very unique smell to the wood, which also imparts a very good flavor and color and smell to whatever liquid is in there. So what happens is, when you fill that barrel with oak, with water or any liquid, the water goes into the wood via the ring porosity, and then it comes out. And it's constantly exchanging. And that tightens up that barrel to where it will not leak. And it's really a marvel of technology, because that's always coming in and out. So it does a couple things. It tightens up the barrel, prevents it from leaking. There's no nails holding that together. There's no screws. There's no fasteners of any kind, except the hoops that are just pressure fit on top of there, tension. So someone had to figure out the circumference of that, because they're all the same size. If you look at a bourbon barrel, whiskey barrel, they're all the same size. Okay? So one thing we talked about was most of those barrels are 53 gallons. So here's a little bit of math. That barrel, my son and I were speculating, because we were throwing them around here, moving them around the shop, and they're probably 40, 50 pounds a piece just with the wood. Why are they that heavy? Well, they have to hold a lot of weight. First of all, those staves we talked about, they're 1 inch thick. That's thicker than this board. And this board would be holding up books on a shelf. So 1 inch thick is a very, very thick board. So 53 gallons. Water, let's do some quick calculations. Water is about 8.3 pounds per gallon. So if we round that down to 8, 53 times 8, 8 times 3 is 24, carry the 2, 8 times 4, 424 pounds plus the barrel. Plus the barrel. So if you fill it with water, just in water weight, you have 424 pounds plus the weight of the barrel, which I think we can comfortably say is about 50 pounds. So if you add 50 pounds on there, you're looking at 474 pounds. The alcohol that they put in there, alcohol weighs a little less. Alcohol weighs about 7 pounds. So 53 times 7, let's see, 7 threes are 21, 35, 371 plus 50 for the barrel 1, 7 and 5 is what? What is that? 12, 421. So you've got about a 50-pound difference between holding water and holding an alcohol, some sort of an alcohol liquid. Okay? And you know, alcohol evaporates. So when they would fill that up over time, some of it goes away. They call that the angel share. It's a term in that industry. But it's going to evaporate. Just like when you use the Perel, like you're doing